Assalamualaikum everyone. Today we are going to see what are activation functions and what are the different kinds of activation functions. First of all, activation function is some mathematical formula, you can say, that takes some input and it gives the output of the neural network. It is connected to every neuron and it outputs the it gives the output of that particular neuron depending upon that whether it's going to contribute in the whole prediction process or not. Okay, this is a simple example of a neural network which consists of one input layer and one output layer, and the input layer contains two neurons and the output layer contains one neuron. And for this neuron, we are gonna explain all the activation functions. In a neuron, there are two steps. Okay, there are two things that happen. First of all, the summation of the weights, and then the results of the summation are passed to the activation function, and then the value from the activation function is returned, which is then passed on. In this case, what will happen in summation is that these weights will be summed up and some bias value will be added if specified, okay, and the result of this, such as y, will be passed to this activation function, okay, and it will result in some value which will be the output of this neuron, of this particular neuron, okay. Now let's coming towards the first activation function, step activation function. It actually output only two values, 0 or 1, you can say, either 0 or either 1, okay. It defines some threshold value, okay. You can define any value of threshold, and here I am defining it 5, okay, such that if the input to this activation function, okay, if the summation result is something greater than or equals to 5, then it's going to output 1. But if this value smaller than 5, then it's going to output 0. So in case it is equal to 5 or greater to 5, then the value of W3 will be 1, or otherwise it will be 0. Obviously, there are pros and cons to step activation function. The step activation function is can be used for binary class activation, binary class classification problem, such that we are going to classify that whether this input belongs to class 0 or class 1. But in case of multi-class classification problem, as we know that it just to give two values in the output, it can never be used for multi-class classification problem. But at the same time, we can see that it's not giving any intermediate values, the same thing, okay. And another thing is that as its values are only of 0 and 1, when we do in our neural networks, when we do back propagation and when we are to update the weights, okay, updates the values of our weights of the neurons, then in that case it do not updates any weights of neurons, okay. This is another problem. Now coming towards the next kind of activation function, here comes linear activation function. Okay, what linear activation function do is, you can say, it passes the input as it is in the output. Let's suppose the result of summation was something like -3, then this activation function is gonna pass -3. If it was something like -6, it's gonna pass -6. If it was something like 100, it's gonna pass 100, okay. It just pass the inputs as it is in the output, okay. If there are drawbacks of this activation function is, as you can see, that it's linear, it's acting linearly, it cannot learn complex functions, okay, it cannot be used for complex problems. But as comparing to the step activation function, it's good in a sense that it's giving a range of values, okay, not just two values, it's giving a range of values. Okay, coming towards the next kind of activation function, sigmoid activation function, it do what? It do some transformation on every input value, okay. It gives a values between 0 and 1, point to be noted, okay. It gives all the values between 0 and 1. The lowest value is 0 and the highest value is 1, and the other values in between, okay. So it do what actually? If some value is something. Let's suppose this point is 8, and let's suppose this point is -8. I'm not sure that whether it is actually 8 or -8 here at the time, but I'm just supposing that it's 8 and it's -2. It's going to do what? For values equals to 8 and greater than 8, it's gonna output 1, and for values for some values which are -8 or smaller than -8, it's going to output 0. For that, it's doing what? Actually, it's saturating our values. Okay, it's saturating our values greater than this number and smaller than this number. It doesn't matter we give it 1000 or 8 or -1000 or -8, irrespective of the difference between them. It's considering both of them 0. It's considering both of them 1. So it's saturating our values. And on the other hand, you can see that if there is a, you can see that with a large difference in input, it's resulting only a very little change in output. Okay, you can see that this distance is larger than this one. Like for a large change in x value for the input, it's resulting a very small change in output. So these are the problems of sigmoid activation function. And another one is that it is not zero centered. Like for example, for input 0, it's not giving us input 0, it's giving us 0.5. So this is a problem. These are the problems. As compared to the previous discussed, it's better, but still it have a lot of problems, and it also causes these. It's due to these of the problems, due to these things, it cause vanishing gradient problem. Okay. Going towards the next kind of activation function, ReLU activation function. It do what? For some part it acts as a linear function, and for some part it acts as non-linear. Okay, for some values of x it is acting as a linear function, and for some values it is doing some kind of transformation such that all the values are considered 0. Okay, so here we can see that for the values of x which are greater than 0, it's going to output them as it is. For example, if the summation output is -6, sorry, not -6, +6, it's going to output 6. But in case if the values are 0 or smaller than 0, for example, if the value is -12 or 0, it's going to output 0. Due to it's this behavior of acting non-linear and linear x, that's why we also call ReLU as piecewise activation function. But you can see that it's 0 at the 0, like it's 0 center. For input 0, it's giving output 0. It's better than the sigmoid activation function. Okay, in that case as well. So as like other function, it also have drawbacks. It's not the perfect, the last activation function. There is also leaky value activation function, which is something like that. I'm not gonna explain here, but it is something like that. The story is something like that. Okay, but I will suggest you people to search on the internet about the other activation functions. I have not covered every kind of activation function, but what I have done is I have not covered every activation function, but I have tried to describe the activation function of every kind. Okay, like step activation function is different from linear, and the linear is different from sigmoid, and sigmoid is different from ReLU activation function. And I hope this would help you in your making your concepts about activation functions. Thank you.